Alrighty, for the honors review, we have just one question. So it says Mr. Gifford surveyed a triangular region of land and sent the measurements. So A was 130 meters, B is 150 meters, and the measure of angle A is 49 degrees, and he sent that to the engineer at the office. The engineer called back asking for more information. He wants you to determine how many, if any, triangles can be formed using Mr. Gifford's measurements. If possible, find the unknown measurements. So what we need to do first is, I already drew these triangles out, so there's probably a pretty good indicator that there's going to be two possible triangles, but let's do the math for it as well. So we need to check the height first. So in order to check the height, you'll see I drew the height for both of those. It's the same for both, regardless of which version of the triangle you'd be using. So if we look at the sine of angle A, so the sine of 49 degrees, that'd be the opposite side, h, divided by the hypotenuse, which is 150. So it's h over 150. Now, if we're solving for h here, if we got to multiply both sides by 150, and we end up with h being 113 meters. Now, based off the information that we know, if our h is less than our a value, which happens to be less than our b value, then we're going to get two different triangles. It's probably a pretty good indicator that we're going to get two different triangles by the fact that I drew two different triangles just to start. Okay, well let's kind of focus just on one triangle. Let's just kind of focus on, I'm going to call this triangle 1. It's going to be a little easier, and then triangle 2. So for triangle 1, let's do the sine of angle A over side A because we know both pieces are there. Let me move this over a little bit because I'm really far over. Alright, so the sine of angle A over little a is equal to, let's find side, or let's work with side and angle B because we know one of those pieces of information. So sine of angle A over little a equals sine of angle B over little b. Now, kind of plugging in the numbers that we know, we have the sine of angle A is 49 degrees over side length A, which is 130, equals sine of, we don't know angle B, so we're going to have to leave that as is, over side B is 150. And since we're talking about triangle 1, let's call these B1s. So B with the subscript of 1. Now to solve for angle B, we got to get that sine by itself. So let's multiply both sides by 150. And with that, on the left side we end up with 0.871. And on the right side we're left with just the sine of angle B sub 1. Now in order to find the angle measure for that, we're going to do the inverse sine of both sides. So the inverse sine of 0.871 is going to be equal to, when we do the inverse sine of the other side, you're just left with the angle, so the measure of angle B. And when we plug that into a calculator, we end up with 60.6 degrees is the measure of angle B. So there's one of our pieces of information. Now, I keep forgetting to add my subscript to 1 because that's only one of our angle B's. There's going to be two possible ones. The other possible angle B, so we'll call that measure of angle B2, since there are two different triangles, it's going to be the supplement to that. So 180 minus that 60.6 degrees. So that's going to be measure of angle B sub 2 for the other triangle is 119.4 degrees. Okay, so now we have another angle for both of those. So now we have two angles in both of our triangles. So let's just kind of find measure of angle C for both of them. Oops, sorry. So for the measure of angle C, for the one on the left, I'll call that C sub 1, it's just going to be 180 minus the other two angles that we know. So it's 180 minus 49 minus 60.6 degrees, which ends up giving us 70.4 degrees. So that angle C1 on the left side is 70.4 degrees. On the right side, we'll do measure of angle C2 is equal to, same deal, just using different measurements. So 180 minus 49 minus 119.4 gives us 11.6 degrees. Okay, so now we have all three angles and we have 2 of the 3 sides. So to find the last side, side C, let me plop these labels in here a second. So angle B on this left one we said was 60.6 degrees. Angle C we just found was 70.4 degrees. On this right one, angle B was 119.4 degrees. And angle C up here, that little one, is 11.6 degrees. Now we just got to find side length C for both of these. So we're going to use, I'm going to zoom out a little, or zoom in a little bit so we have a little more room to work. We got to use the law of sines one more time to find angle C. So we got sine of A over little a, use those because those are not rounded, equals the sine of, we'll call this C1 over little c1. Plugging in what we know we have the, there we go, the sine of 49 degrees over 130 equals the sine of, we know C1 was 70.4 over little c1. Just like normal, cross multiply and divide. So we end up with, I'm going to move it over here a little bit. C1, sorry, didn't mean to zoom in. So we got C1 times the sine of 49 degrees equals 130 times the sine of 70.4. To get C1 all by itself, we got to divide both sides by the sine of 49. So that'll end up leaving us with just C1 all by itself, and at that point we just plug that into a calculator. We end up with 162.3, and we're using meters here. So that one will have a side length of 162.3 meters. I'm running a little large, so give me a second as I move some things around, shrink some things down a little bit. Let me just shrink all this down. Okay, now I have a little more room to work. All right, I'm going to zoom in. So we're going to do, for this one, sine of angle A over little a. Now we're focusing on the second C, so we're going to do sine of C2 over little c2. Again, we know sine of A, so the sine of, or we know what A is, so sine of 49, little a was 130, equals the sine of C2 was 11.6. We don't know little c2. Same deal as we did on the other side. Cross multiply. So when we cross multiply, we end up with C2 times the sine of 49 equals 130 times the sine of 11.6. Just like we did on the other side, we've got to divide by sine of 49 on both sides. So our sines of 49 cancel off there. We're left with just C2 equals 34.6 meters. So now I have all the measurements for these triangles. So kind of putting those back onto the triangles. We just said C, this was C1, equals 162.3 meters. And over here, C2 was 34.6 meters.